Have you ever stepped outside and the air just felt thick? Kind of heavy? Like the smog from yesterday's traffic just decided to stick around? Well, I'm here to tell you it is not your imagination. Today, we're going to peel back the sky and take a look at the invisible forces that decide if we get a crystal clear day or one where we're stuck under a dome of smog.
And that really gets us to the heart of the mystery, doesn't it? Why doesn't all that pollution just, blow away? What invisible cage is holding it captive right over our heads? To figure this out, we need to start thinking like atmospheric detectives. So let's officially open the case file. Our investigation today is all about this phenomenon of trapped air, the real culprit behind those hazy, gross, stagnant days in the city. You know that feeling, right? That heavy, persistent air? That's our first major piece of evidence. It's a real, tangible clue that something strange is going on in the layers of air way above us. And this isn't just a feeling, it's a real weather event, and it has a name. It's called an atmospheric inversion. Okay, so normally, air gets cooler the higher you go. This lets warm, polluted air from down here on the surface rise up and just float away. Simple. But during an inversion, everything gets flipped upside down. A layer of warm air actually forms above a layer of cooler air, and it acts like a giant invisible lid on the sky. This inversion, that's our atmospheric crime scene. It's the lid that stops pollutants from escaping. All right, so let's dig in. And like any good detective, we're going to start by looking at the usual suspects. All the common factors we know can mess with the air around us. And sure, of course, things like wind, or whether you live in a valley, or even a good hard rain, they all play a huge part. A strong gust of wind or a downpour can totally clear the air in minutes. But here's the thing. On their own, these factors don't really explain why that atmospheric lid forms in the first place. For that, we've got to look at a much bigger, much more powerful force. And that, my friends, brings us to our prime suspect, atmospheric pressure. It's this immense, invisible weight pressing down on everything all the time. And how it behaves is absolutely the key to cracking this case. So check this out. You can really see the two systems in action. Under a high-pressure system, air is slowly sinking and warming up, and that creates super stable conditions. That sinking motion is exactly what forms our inversion layer, our atmospheric lid. But on the flip side, in a low-pressure system, air's rising. That creates clouds and storms and weather, the perfect escape route for all that pollution to get out of town. So how on earth do we track this invisible force? Well, meteorologists use something called isobars. The easiest way to think of them is like contour lines on a map, but instead of showing mountains and valleys, they show air pressure. When these lines are jammed really close together, it means strong winds. But when they're spread far apart, that means stable, calm, high pressure. The perfect conditions for our smog-trapping lid to form. But just when you think you've got it figured out, our mystery takes this absolutely fascinating turn. See, air doesn't just flow on a nice, neat, straight line from high pressure to low pressure. No, there's a global plot twist that changes everything. You'd think, right, that wind should just blow directly from a high-pressure zone to a low-pressure one. Kind of like water flowing downhill. Makes sense. But it doesn't do that. And the reason is this planetary scale force that is just deeply weird and counterintuitive. Meet the Coriolis effect. Here's the deal. Because our planet is constantly spinning, any object moving across its surface, whether it's a cannonball or a bit of air, gets pushed off a straight path. This effect is our big plot twist. The Earth's own rotation literally stops the air from taking the simple, direct route. So here's how it all goes down, and this is so crucial. Air tries to go from high to low pressure, but the Coriolis effect grabs it and forces it to spin instead. And this is what creates those huge swirling weather patterns you see on the news. The low-pressure cyclones that bring storms, and the high-pressure anticyclones that bring that stable, clear, and sometimes very smoggy weather. Okay, now to fully get why these pressure systems do what they do, we need to zoom way in. We're going from the planetary scale all the way down to the molecular scale. Turns out this whole atmospheric drama we've been watching is actually directed by just a few fundamental rules of physics. First up is Boyle's law. Put simply, if you squeeze air into a smaller space, its pressure goes up. That's it. Now think about our high-pressure systems. As air sinks towards the ground, it's being squeezed by all the air on top of it. That's a huge part of how that stable, high-pressure lid gets formed. Next, we've got Charles's law. This one's pretty intuitive. You heat a gas, and it expands.
It gets less dense. This is literally how a hot air balloon works. It's also why that warm, polluted air at the surface wants to rise up and get away. But this law also explains our culprit, that inversion layer, where sinking air gets heated up by compression, creating that warm lid up high.
And finally, Avogadro's law. It sounds complicated, but all it's saying is that if you add more molecules into a space, like say by pumping tons of pollutants into the air, you're going to increase the pressure. All that extra stuff from our cars and factories just gets packed in tighter and tighter under that inversion lid, making the smog even worse. So you've got these three basic rules, right? Squeeze it, pressure goes up. Heat it, it expands. Add more stuff, it gets bigger. These three simple ideas are the fundamental building blocks for how the air works, and when you put them all together, you get the master key that unlocks this whole system. And this is it. PV equals nRT. This one, simple equation, the ideal gas law, connects all the dots for us: pressure, volume, and temperature. This is the single line of code that runs the physical behavior of our atmosphere. It's the physics behind the high-pressure lid and the low-pressure systems that let our cities finally breathe. And just like that, we've solved it. Case closed. That trapped polluted air hanging over a city, it's not caused by just one thing. It's basically a conspiracy between a high-pressure system creating a lid, the Earth's own spin locking it all into a stable pattern, and the fundamental gas laws dictating how every single molecule behaves. Which leaves us with a final thought. We've just made some of the huge invisible forces in our atmosphere visible. It really makes you wonder, doesn't it? What other elegant, unseen systems, all governed by their own fundamental rules, are quietly shaping our world every single day?